So moving forward, we're going to pick another side, essentially, right? So I'm going to pick a new elevation of this building, or a new face of the original loft, and I'm going to use that to start to subdivide.
Will that make the computer explode?
Huh?
Will that make the computer explode?
Well, no, you just turn off some of your other geometry, and then it should still render well enough. And we could even do it in the same place if you want, and then model over top of it something else if that's what you want. Okay. So to get started, guys, we're gonna kind of begin with the same method that we began, down this path over here, where we were developing that facade component. But we need to basically determine which surface, again, we're going to operate on. So for me, like I said, I'm going to pick a different one so that I can show them both at once. But you could use the same surface or the same face if you want. So I'm going to copy the deconstruct brep and the list item that comes directly off of my original lofted skin. So that original lofted skin, it should be pretty close to the origin of your definition. All right. And to make it easy on myself, I'm just going to pull this down. And if you really want to make it easy, you can do a big link, but I'm just going to make my wire display faint so that I can see that it's connected, but if I look up here, I'll know that it's not a part of this definition.
So we just drag that somewhere random?
It's still connected to the original loft, right?
Yes, still connected to the original loft. I wouldn't say random. I would say that you probably have an idea of how you want to organize the file, and you should place it in such a way that it makes sense to you. All right. So like I was saying, I'm going to pick a different surface. So if I turn this list item on, I'll see what surface I'm working on. And I just want to pick this one right adjacent to it, which would be that one right there. Surface number 1.
So how do you pick it?
You change your list item.
Oh, okay.
So with that one, we can begin to start to operate on this a little bit. So my first thought here, and I'll describe what I'm trying to do, is I'm going to deconstruct a surface box into its component surfaces, well, component parts, because it has points, lines, and planes. And then we're going to move forward looking at different ways of modeling around the components that you can then deconstruct using surface box. So really the first step is to subdivide the surface. So when you subdivide it, it's the same thing that you've been seeing. You go to Math, Domain, Divide Domain Squared, and you should be well acquainted with this configuration now. Remember, you've got a surface that goes in. So the surface goes into the I input, the domain. And then you have to set how many subdivisions you want. So I'll do 0 is less than 25. Plug similar counters into the U and V and then set them. So I'll start with 11 and 7. Just throwing that out there. And then you go under Surface, under Utility, and you grab IsoTrim. And remember, the surface gets plugged in, the origin surface gets plugged into the surface of IsoTrim, and then the domain that's created gets plugged into the domain input. And this is what you should see. So for me, I'm trying to get something that's nearly a square, but doesn't exactly have to be. So, you know, something that's somewhat rectilinear like this is perfectly fine. What you're seeing here is actually just that the two grasshopper surfaces are coincident. So focus on the lines, not these weird fuzzy overlapping grids. Or you can turn the original surface off. All right, so here's your first lesson in attractor points when it comes to facades, right? So we're going to look at how do you create dynamic facades that react to sun location or something like that. And we're going to begin actually with a actually, hold on. Oh, you know what? I did a misstep here. Rather than subdivide surface, I know what I did differently. You can actually do a surface box directly off of that. So when you go to, and where was that again? Utility, transform, morph. So under transform and under morph, when you drop in surface box, take a look at the input, right? So the input also asks for an origin surface. It asks for a domain, very similar to isotrim, and then it already jumps you a step ahead and it gives you a height. So we can plug it in precisely the same way that we would with subdivide surface, and then we can just plug in another slider, and I'll just leave the same numbers on there. Plug in another slider to the height, and from here we can change how thick that surface is going to be. Okay, so let's take a look at what that actually is. It is a box, and a box comes with certain properties, but you might think that it's more complex than it really is. So ultimately, all you have to do is go under Surface and Analysis and drop in another deconstruct brep. Because remember, breps read as if they're solids, and a box is a solid. So if you can deconstruct it with deconstruct brep, you know, it's a pretty good idea to do so in most cases. Alright, so I'm going to turn that original surface box off. Actually, I'll leave that one on. And I'm going to turn deconstruct brep off. So here's the really cool part. If you have the surface box alone, you can create what's called a boundary volume. Yeah. So a boundary volume will take a series of surfaces. As long as the edges are aligned, it'll actually turn that back into a solid for you. So while, you know, each of these twisted boxes were coming out and we need to actually deconstruct it into something else, we can reconstruct those surfaces into a boundary volume under free form, I think. Or utility. Sorry, I need to find where this is again. Intersect. Shape. Ah, yeah. Boundary volume. So we take each of these faces in their separate groups, and we can plug it back into boundary volume. And then the output is a solid, which is essentially, I mean, we essentially kind of just translated out of its original form and then back into its original form of a solid box. But I want you to be aware of that because in some cases you can collapse everything together into a volume and deconstruct it into a what's called a branch of a tree, right? So we'll get into that probably tomorrow or next week, but just know that sometimes you need to deconstruct it, break it down, and then reconstruct almost exactly the same thing. So boundary volume is under intersect and shape. We'll need that, but just put it up there for now. So here's what we are going to do. Turn that off too. Actually, you know what I'll do? Before moving on, I want to make sure you're all caught up to this so I don't confuse you, because we're going to get into a lot of point stuff coming up. Sort of. Sort of, but not really.